We're now going to look at the type of trigonometric questions that can be solved with the use of a triangle. The important part with this type of section is to make sure that you can determine in which quadrant you need to draw your triangle. So step one is always going to be find the correct quadrant. Step two would be to then draw the triangle. Then the next step would be to fill in the numbers. So that means filling in the numbers in the correct place, and then we'd probably have to use Pythagoras, and then you simply solve. But this only makes sense if we have a look at a few examples. So on the next slide we're going to look at quite a few of the examples. These questions usually take on the following format. They'll give you a statement that says if sin or if cos or if tan is equal to some ratio, and then they'll tell you a little bit more about the angle, and then they'll say find the following. Okay, so step one is to find out in which quadrant we are actually in. So what we do is we draw ourselves a cast diagram, and then what we do is we read the question. So it says that sin theta is equal to this. Now that over there is a positive number, so that means we could be in this quadrant because we know sin's positive there, but we could also be in this quadrant because all of the trigonometric ratios, or sin, cos and tan, they are all positive in that quadrant. And so we have to look at the next piece of information, which tells us that the angle has to be between 90 and 270. And so that 90 and 270 is this quadrant and this quadrant. And so the answer, or the place where we have to draw this triangle, is going to be over here in quadrant 2, because that is the only quadrant that satisfies both conditions. Now what you need to do is construct a triangle within that quadrant. What's very important when doing this triangle is that you always have a line going back to the x-axis. So that'll be this line over here. You don't want it to go horizontally like that. That's incorrect. So it must always go to the x-axis. Then what you do is, some teachers are going to tell you to then draw an arrow going like this, where this over here will be theta. Alright, but don't let that confuse you, because this doesn't now mean that this little angle here, we don't have to then go say 180 minus theta. Trust me, all you do is you just pretend that this is theta here, and then you just use this triangle as you would normally use it. Okay, so now what we do is we go fill in the values, but first we need to talk about something, because I've seen that some teachers like to use the X, Y, and R method, which is not a bad method, but it has its downfalls. And so the method I like to use is the SOHCAHTOA method. And if your teacher ever tells you that you can't or whatever, trust me, you are allowed to use it. They might not be happy with it, but that's fine. It's not wrong. So SOHCAHTOA means that sin is always equal to the opposite over the hypotenuse, cos is always adjacent over hypotenuse, and tan is always opposite over adjacent. The XYR method, as I said, does work, but you need to know how to use it very carefully, because sometimes it definitely has got its downfalls. Alright, so if we look at SOHCAHTOA, we know that sin is opposite over hypotenuse, and they've told us that the sin is 3 over 5. And so if we look at this angle over here, the opposite of that, they've told us, should be 3, and the hypotenuse should be 5. What you then do is you use Pythagoras and you try to solve this last piece over here, and what you're going to get is a 4. But now this is a very important step. You have to look at each of these three numbers, the 5, the 3, and the 4, and you have to ask yourself, based on where they are found on the diagram, should they be positive or negative? And what you would find is that this 4 is a negative because it's an x value. It's running along the x-axis, and it's on the left-hand side of the x-axis. So it's or on the left side of the x-axis. So it's a negative 4. Okay. So now our triangle is completely filled up, and so now we can answer the actual questions that they would like us to answer. And so the first question would like us to find cos theta. Now, as I said, theta, yes, it technically is this thing on the outside here, but you can just pretend that it's in the middle of in the inside of this triangle. Okay, this will always work. So cos is, if we look at this, it's the adjacent over the hypotenuse. Okay, so that's going to be the adjacent, which is minus 4, over the hypotenuse, which is 5. And so that's going to be minus 4 over 5. The next one says 2 tan theta. What that means is see whatever tan theta is, and then just multiply that answer by 2. So tan, if we look at this over here, is the opposite over the adjacent. So that's going to be 3 over negative 4, and so it's going to be 2 times negative, sorry, not negative, 3 over negative 4, and so we can think of that as 2 over 1, so we times top, bottom times bottom, that's going to give us 6 over minus 4, and if you simplify that, the number 2 can go into both, and so that becomes 3 over negative 2. And that's the answer. Let's go into another example. Actually, I'd just like to mention something very important. Many students that I teach, what they do at this point is, for example, with A, they see that cos theta is equal to negative 4 over 5, and then they go use shift cos. But remember, shift cos is used if we want to find the angle. We're not trying to find the angle, they want us to find cos of theta. So they want that whole thing. And so 4 over 5, or negative 4 over 5, that is the answer. But if the question asked you to find theta, which is the actual angle, then you would go and do the whole shift cos. Okay, and that's not typically a question that they ask in this section. So here's another one. They start off by telling us that cos is something negative this time. Okay, so what we do is we draw ourselves a cos diagram, and then they're telling us that cos is negative. So cos is negative in this quadrant and this quadrant because it's positive in the other two quadrants. And then they tell us that the angle must be somewhere between 180 and 360, which is this quadrant and this quadrant. And so the triangle will be drawn in this quadrant over here because that quadrant satisfies both conditions. And so we can now draw our triangle. And then please remember, you must always draw a line that goes back to the x-axis. Then, no matter what your diagram looks like, really, some diagrams are going to have it going all the way around like that. And then it's going to say theta. Don't feel like you have to try, say, something minus something to try find this little corner angle. All you do is you just make this whole question about that little corner angle on the inside there. It's always about that little corner angle. Alright, the next step is just to go fill in everything on the diagram. Let me quickly write SOHCAHTOA. So they're telling us that cos is negative 3 over 5. Cos is adjacent over hypotenuse. So the adjacent is 3 and the hypotenuse is 5. Now many people panic and they say, but where's the negative? Is it for the 3 or for the 5? It's based on where it is on the diagram. So that 5, which is the hypotenuse, should always be a positive in these types of questions. That 3 is an x value because it's going along the x-axis and it's on the left side of the x-axis, which is negative. Okay, and that's where they got that negative from. We then do Pythagoras, and if you do Pythagoras, don't worry about the negative over here, because remember Pythagoras is only looking at the lengths. It's not worried about negatives and positives. So if you do Pythagoras using 3 and 5, you're going to get an answer of 4. But then look at where that is on the diagram. That is a y value, and it's underneath, or it's in the negative y. It's a negative y value. Okay, so that's minus 4. And so our triangle is now complete, and we can answer all the questions. The first question asks us to find sin theta. Now, sin theta is opposite over hypotenuse, and so the opposite is minus 4, and the hypotenuse is 5. And that's that answer. B is asking us for 2 times tan theta. So remember, we just used tan theta. Tan is opposite over adjacent, which is going to be equal to, opposite is minus 4, the adjacent is minus 3. And then we should times this answer with 2. And so I'm going to times top first, which is minus 8. Bottom times bottom, which is minus 3. The minuses cancel, and so we end up with 8 over 3. Now, in other types of questions, they're not going to specify a quadrant. So then what you do is you just draw yourself a random little triangle. Okay, so those types of questions are going to look like this. They'll say something like, if sin of 18 is equal to a, express the following in terms of a. And then they'll give you a whole bunch of stuff over here. So then what we do with these types of questions is we typically just go draw ourselves a little triangle. I can assure you that there's only a few types of questions that they ask, and I'm showing you all of them now. So if you can just learn all these different types, it should be fairly easy. So they're telling us that the sin of 18 is a. Now we know sin is opposite over hypotenuse. And so what you got to do, the little trick is to think of this a. Remember, a is the same as a over 1. Okay, so then what you do is you just make a little, the angle that they're using is 18, so we'll just say 18. And then they're telling us that sin 18 is a over 1, so that means the opposite should be a, and the hypotenuse should be 1. We can then quickly use Pythagoras to find this length over here. So we know that 1 squared is equal to a squared plus, I'll just call this other one x for now. And then we just get x by itself. 1 squared is 1. I'll take the a squared to the left hand side, so it looks like that. And then to get x alone, you just take the square root. And so that length over here is 1 minus, or the square root of 1 minus a squared. Now that our triangle is complete, we can answer the questions. So the first one asks us to find the cos of 18. So we go to our little 18. We know that cos is adjacent over hypotenuse, and so that's going to equal, the adjacent is the square root of 1 minus a squared over the hypotenuse, which is 1. Okay, so that's that question done. The next one is sin 72, which obviously is not the 18, but it's a little trick that teachers try and do, but if you see it a couple of times, it won't really catch you out. If you had to add all these angles together inside this triangle, they should add up to 180. And so if you had to go solve this angle, you're going to end up with 72. Okay, so then the sin of 72, so you start off at the 72 degrees and you just see what sin is. Sin is opposite. So the opposite of 72 now, don't use the 18. So that's the square root of 1 minus a squared, and the hypotenuse is 1. And that's that question finished already. Okay, so that's that one. So here's a very good question, tan 198. Now remember a couple of videos back where we did reduction. Well, let's do reduction. Okay, so remember, if we had ourselves a little cast diagram, we would know that this is the 180 minus x quadrant, and this is the 180 plus x, and this is 360 minus x. What you would do is you would first identify where the 198 goes. That would be this quadrant over here, because remember this is 90 degrees, this is 180, this is 270, and this goes up to 360. So then what you would have to do is write the 198 as 180 plus something. So 180 plus 18 gives you 198. Now at least you've got your angle written in a format that we have got on the cast diagram, and so we can just reduce that to tan 18. Then what we do is we just make sure tan is positive or negative on that quadrant. We know that tan is positive in that quadrant, and so we end up with tan 18. And so tan 198 is the same as tan 18. And so now we can come back to the triangle because there we have 18. And so if we use our triangle, we know that tan is opposite over adjacent. So the opposite of 18 is a. And the adjacent of 18 is the square root of 1 minus a squared. And that's it. So somehow each of these questions will come back to the triangle. Here's another one we can try. Notice they're not giving you any extra information about the angles, or they're just telling you they're not giving you enough information to be able to know which quadrant you are in. And so for these kinds of questions, you just draw a random triangle. It was the questions that we did just before this where they gave you a statement such as the following, but then they also added something after that with regards to the angle being bigger than 90 and smaller than 180. If it's one of those, then you have to draw it in the correct quadrant. If it's one like this, you just draw yourself a triangle. So I've drawn a triangle with an angle of 32 degrees. Now remember, the trick is when they say cos 32 equals b, you should just think of that as b over 1. And then if we write SOHCAHTOA again, we know that cos is adjacent over hypotenuse, and so the adjacent is b and the hypotenuse is 1. You would then use Pythagoras to find this one, which I'm going to call y. So it would say 1 squared is equal to b squared plus y squared. I'm going to keep the y on the right and take the b squared over, and 1 squared is just 1. Then what I'm going to do is just square root to get y by itself, and that's going to give us y is equal to the square root of 1 minus b squared. Now we can start the questions. So have a look here, sin 148. I'm hoping by now you guys are starting to realize that that needs to be reduced first. So sin 148, well, let me first do a little cast diagram. So this is 180 minus x, this is 180 plus x, 360 minus x. And so 148 would be somewhere in this quadrant because it's between 90 and 180. And so I'm going to move it over to here. So sin 148 must be rewritten in this kind of format. So it's going to have to become 180 minus something. Now if you do that on your calculator, 180 minus 32 is what gives us 148. And so because of the fact that this kind of format is on the cast diagram, we can simply reduce this to sin 32. If what I'm doing now doesn't make sense, then you just need to watch the video on reductions again, because I have explained it quite in depth in that video. And so we've just reduced this whole thing to sin 32. And so this just becomes sin 32. And look here, 32 is on the diagram. Alright, so now we just take the sin of that. We know that sin is opposite over hypotenuse, so the opposite is the square root of 1 minus b squared over the hypotenuse, which is 1. And so that's the end of that. That's the end of number 2a. The next one says tan minus 32. Now that is not the same as tan 32. So remember in our video on reductions, if that doesn't fit into the cast diagram, then you are allowed to add 360. And so if we add 360 to that, we're going to end up with the tan of 328. Now 328 on the cast diagram would end up in quadrant 4. And so we have to rewrite tan of 328 in that kind of format, which is the 360 minus format, and it's 360 minus 32, which gives us tan 328. Okay, so now because we have something that resembles the cast diagram, we can reduce that to tan 32. And then remember, tan is negative in that quadrant, and so we'll just put a little negative in the front. Luckily though, 32 is on this diagram in the triangle, and so we can just look at the tan. Tan is opposite over adjacent, so the opposite of 32 is the square root of 1 minus b squared. The adjacent is b, and so negative tan 32 is going to be equal to the square root of 1 minus b squared over b, and then we must just remember to put the negative in the front. Perfect, and that's the end of that question. Another kind of question, and the last type we're going to look at in this video, is when the question has already got a triangle drawn for you and you just have to fill in the values and then solve. It's actually quite easy. It's easier than the other ones where you have to determine the quadrant. And so those kind of questions will look like this. So here they've gone and drawn a it looks to be like a triangle. So all that you need to do in these types of questions is you just finish the triangle, okay? So you just draw it downwards like that. You don't want to go to the side. You always want to go to the x-axis. Then you need to analyze this coordinate carefully. That is an x value and a y value. So it's telling you that the x value is -3. So give that some careful thought. If you give that some thought, you'll understand that that means that this length here is 3, because that's its x coordinate, and this y value is 4, so that's this value here. So that length is 4. And then based on where those numbers are on the diagram, you can fill in the negatives or the positives. Then we just use Pythagoras to find the longest side, and if you do that, you're going to get an answer of 5 over there. Another thing is, look at this theta angle. It's on the outside, but remember, don't even let that worry you. All that you need to do is just pretend that everything is happening from this corner angle here. Okay? So the first question says, work out the sin of theta. Remember, if we use SOHCAHTOA, sin is opposite over hypotenuse. The opposite is 4, and the hypotenuse is 5. Always based on that angle over there. The next one says cos squared theta. Remember, if you see that, you should just think of it as cos theta, and then whatever that becomes, just square it. So let's look at cos theta. Cos is adjacent over hypotenuse, which is -3 over 5, and then we should just square that. So -3 squared is 9, and 5 squared is 25. And the last question for this video is one where they've drawn the diagram, so you should just complete it. So you just draw a little line going like that. Remember, always to the x-axis, not to the y-axis. Then analyze these points here. Remember that 3 is an x value, so that would mean that this length here is 3. This value here is a y value, so that means this would be 4. But this is going down, so that's why it's a -4. If you then do Pythagoras again, you're going to end up with a value here as 5. Never make that a negative. It's always a positive, that diagonal. Then once again, their angle's going all the way around. Don't worry about that. You just work from this corner angle over here. Now that our triangle's complete, we can solve. So tan of theta. So remember, even though theta is on the outside, you just work from this corner angle. Tan is, let me just write SOHCAHTOA again. Tan is opposite over adjacent. So the opposite of that is -4, and the adjacent is 3. Sin squared theta. So remember, think of this as sin theta, and whatever that is, square it. So sin theta would be the opposite over the hypotenuse, which is -4 as the opposite, over 5, which is the hypotenuse, and then you square that. So -4 squared is +16, and 5 squared is 25. And that's the end of this video. Thank you very much for watching.